I want to take you guys back to August 2024 and this particular video, this one actually. If you are new to building agents, and if you probably not built any agent at all so far, I strongly recommend that you go through this video. This doesn't use any SDK. This doesn't use any library like LangChain, LangGraph. We've written a custom agent from scratch using Python, right? And if you understand how to build this, then your understanding of writing harness, a good harness, or becoming a good harness engineer is going to be that much, or your at least your understanding is going to be that much more better, right? Because today the topic that we'll be discussing is harness engineering, and I want to first walk you through the deck that I've created, and then we'll probably come back to understand how our agent that we wrote almost 2 years ago, and the code is still available on my GitHub repo, uh, is still relevant to the concept of harness engineering that you're seeing here. All right. All right. Let's try and understand what harness engineering is. And ever since the term harness engineering has come out, the definition of agent has also changed, or at least shortened a bit. Uh, and if I can write that here, the agent, they say, now is essentially an agent is equal to model plus harness. So what is the harness? If you think about all the components of an agent, except the model, that is a harness. Let me try and explain. A prompt is a component of an agent. Tool calling, basically you have tools, and tool calling is part of an agent. Guardrails is part of an agent, is a component of an agent. Memory is basically a component of an agent. And you can think of human in the loop is also a critical component of an agent. And sub-agents, obviously, are also part of an agent, right? So an agent entails so many components: the prompts, tool calls, guardrails, memory, human in the loop, or checkpointers, sub-agents. I think I forgot the most important bit, which is basically the feedback loop. All of these essentially are key components of an agent typically, and I think you have worked with this in one capacity or the other. Now, harness engineering essentially is structural software layers around the model, that is the prompt, the feedback loop, the tool calls, the memory, the human in the loop, the subagents, to essentially form a reliable working shippable system. It's a software that essentially makes all of these components to work together to make an agent into a working shippable system, basically a reliable system. That's what harness engineering is. How you basically build these layers around the model is what harness engineering is. And you obviously use code to do that, right? Now, we'll quickly look at each of these layers at a very high level, and we'll try and understand them before we go deep into the specific layer for this particular video, which is the loop. Now, the loop essentially, which is the closest to the model, the layer closest to the model, has just three responsibilities. Its job is to call the model, its job is to then check the output of the model, and if certain conditions of the output, that is, if the exit conditions are not met, its job is to call the model again. That's what loop does. Now, if there was no loop, which means that the agent had pretty much just one single input and one single output from the LLM. Now, is that possible in if you want to build an autonomous system, if you want to build reliable enterprise grade agents, a single call LLM or single LLM call won't work. We know that. So the loop becomes the most important layer actually in an agent, right? The next is basically tools and permissions. In fact, let me actually just clean. Oh, I'm sorry. Let me actually clean this up. The next layer is essentially the tools and permissions. So now the agent has the capability to loop, right? Now it can call the models. The model has access to tools as well. Now the model decides that you need to call this tool. How do you call it? You need to write. You need to basically write the code for it. That's part of the harness. So this is where tool calling happens. Remember, an agent can have access to multiple tools depending on the kind of problem or kind of complexity it is solving. So you need to essentially have a loop. If there is no loop, means the tools might not work as well. And you cannot expect one single output and one single LLM call to basically solve for it. You can't. Even if you're chaining it, that's not an agent, right? That's a workflow. You know the definitions. But it's very important to understand that if there is no loop, the tools and permission layer doesn't exist without it. Now, as you're calling the model in loop and you're, passing the output of the tools to the model and you're doing that iteratively, your context window, you're basically hitting the limits or testing the limits of the model's context window, right? And this is where this particular layers to comes in. You need to manage the context really well. Obviously, even if you're working with today's frontier models, which have a context window of 1 million tokens, you still need to ensure that the right information is or the right context is going, the right amount of context also is going to an LLM. And this is where the layer of context engineering can help. And this is where you basically summarize uh, you summarize you basically trim, compaction. All of this happens in this particular layer. And as you can imagine, if there is no tools and if there is no loop, context engineering is probably not even required, right? Because you're pushing everything to one single call and you're expecting the output and you're working with it. So if you're working in a loop and you're calling tools, context engineering becomes that much more important. And that's layer three. When you're working with critical context and you're working with a lot of tools and you're working in a loop and you're iterating, you need to ensure that the execution, the tool execution, or the agent's reliability is established. And you can only do that when you either introduce checkpointers and also human in the loop. And finally, it's the multi-agent orchestration. This is where several agents hand off work to each other. And we will dive into each of these layers in the upcoming videos. But today, we'll go deep into the loop layer. All right, now let's try and understand why the loop actually exists. Uh, if you remember back in 2024, Anthropic had released this famous article, Building Effective Agents, and they had defined what a workflow and what an agent is, and basically a difference between them. Let's quickly look at the definitions here. Workflows are systems where LLMs and tools are orchestrated through predefined code paths. Here, essentially, I mean, if I can put it in different words, let's say that you're trying to build an application, and if you know the steps beforehand, that is, there is step 1, step 2, step 3 to accomplish that particular task, to accomplish the task of the application, then that's essentially a workflow because you know the path. The path is predefined. On the other hand, and this is the definition of an agent, agents are systems where LLMs dynamically direct their own processes and tool usage, maintaining control over how they accomplish tasks. So the agents basically use the loop harness or the loop layer to take or to let the model decide what should the next step be. And it happens over iterations. And we'll actually look at the illustration and understand. So let's go back to the deck. So on the left side, you're seeing that this is essentially a chain of nodes, or maybe a chain of LLM calls that is happening. Essentially, it's a fixed path, uh, and we know the fixed path beforehand. We know this even before we are writing the application, that to the goal of this application, let's say it's to generate a marketing article. So I know that this could this could be, let's say, this could be a researcher node. This could be, an article writer. Let's call it a writer node. And this could be, let's call it an editor node. It basically validates or edits the article. So the researcher has one simple job. It needs to research. It could also have access to tools like Tavili search. And once it basically generates a response, it feeds that output to the writer node. And when I say the this node is basically giving an output, and there is essentially a gate or a code that writes that takes a particular output from this node and gives that or feeds that as input to the next node, which is the writer node. Writer node takes that input and essentially generates, let's say, a blog or article. And the same step again, that the output of the writer node becomes the input of the editor node. The editor node just goes through any fact checking or any uh, grammar correction or format correction, anything that it needs to do to basically give the final response. Now the challenge with this is that, if something fails here, there is no feedback mechanism. There is no feedback loop here. So if this fails, the pipeline fails. You could probably write some gates to basically redo the same step that you've done. But if the validation, if the editor basically decides that the quality of output that was given to it by the writer node is not good, unless and until you have explicitly written that loop, this is not going to work, right? So in simple words, you might have processes where you beforehand know what those steps are. Then you basically can write those as maybe a chain of LLM calls, and that could be called as a workflow. However, in agent, we know that the model decides when to answer, that is basically respond back, and when to essentially call a tool. Uh, and this is only accomplished through the loop layer. And if I can go back to the first slide, this is accomplished by the loop layer. And we'll see this in action in a bit. So I had written this particular agent almost 2 years ago to essentially build a deeper understanding of how the loop works, or how the loop helps a model to essentially make decisions, right? Whether it should, call a tool next or return the response back to the user. Now, this harness is a very simple harness. I had written just the tool bit, no MCP integration, nothing. But we'll quickly debug and see how this works so that we have a good understanding of how if you're writing your own custom loop-based harness for an agent, let's see how that works. Time and temperature in Bengaluru. So control is there. We'll see what are the two different tools that it is adding. So you see that we instantiated the agent tool or the agent class, I'm sorry, and the agent class looks something like this. It has a couple of methods. It has a method to essentially add tools, basically add it to a list that we've created. And it has a JSON parser method. You can ignore this. We don't need this these days because the LLMs respond, at least the frontier LLMs respond with good structure. There is a process input method. This is where we basically call the LLM using the query LLM method by composing a prompt. That is, in the prompt, we add the tools that we have access to and a system prompt. And we also tell it what kind of format that we are expecting. We are expecting a format which has two keys, action and arguments. We call the LLM and then we basically parse the response of the LLM. We iterate on one particular condition. We say that, if the argument, that is action, matches with any of the tool names, we simply invoke the tool or call the tool. And just to show you how the tool looks like, the tools are the time tool and weather. It's a very simple implementation. We have the name, description, and the use method, and this is where we actually call the tool. So as you can see, the weather tool uses the Open Weather Map API to essentially get us the weather information given a location, right? So let's actually debug the steps, right? So I know that the input is what is the current time and temperature in Bengaluru, and I will add those tools first. We created an instance of the agent class. We added those tools, and we've sent this information to the run method now. The run method essentially has the most important bit that we are talking about, the loop, right? So it is adding the tools. So it is here, and it is in the run method. The input obviously still is what is the current time and temperature. Now we enter the loop, and in the very first condition, it is checking if user input has any of these words, exit, by, or close. And if this particular condition matches, then we respond back to the user. Essentially, we print that see you later. That's it. But we know that that's not the condition. We don't have any of those words. So we simply hit the process input method. And this is where and we'll actually see what is happening there, right? So the first thing that we're doing is, we are composing a prompt. You can ignore the memory bit. Memory is also part of our harness, but we'll not take that into consideration now. We'll do that when we are talking about memory in general. We're first essentially creating the context. Context is basically we are adding memory or the previous previous conversations that we've had, and you'll see that in the second loop when we do that. We are also adding the list of tools that we have as context. So what we do is we basically create a sentence of the name of the tool in the description, and we simply add that as context. We compose a prompt, and if I can show you what the prompt looks like, the prompt is basically looks something like this. What is the current time and temperature? Given the available tools are this, and there is a system prompt. We're also giving it the expected response. The expected response is that I'm expecting two keys, action and the arguments, right? So, and if the action, if it basically finds a tool for the given input, then it needs to return the tool name as action. And if it is there are no tool calls to be made, you needs to basically respond with the action value as a respond to user, and you will see that now. Okay, so we'll add this. We're calling the LLM now. The LLM has returned a response. We'll parse the response now. And the first thing that we are doing is we'll iterate over the list of tools that we have, and which will check if the response that we got from the LLM has any of the tool names. So as you can see, the response dictionary that we got from the LLM is having an action called time tool, and it has also generated the arguments that we need to send to the tool. So it's saying the city is Bengaluru and the time zone is Asia Kolkata. So we will we know that that particular condition matched because we have a tool called time tool, and we are simply invoking the tool now, as you can see. And if I can go there, I'm in the time tool method now, and we are identifying what the argument is because we know that we are checking for a dictionary with key called time zone, and we've identified the time zone. It is Asia Kolkata, and we are simply generating the current time for that particular time zone, and we are returning the response like that. The current time is this. So we have written that particular response from the tool, and what we'll do now is we will, and if I show you the response, the current time is, so the response from the process input in our iteration, the first time the LLM called is the current time is this. But remember, I'm asking both time and temperature. Now, if I had a workflow that looks something like this, and if I can go back to, if I had a workflow that looks something like this, there is no way I would be able to essentially break down a task and hit the tools and then capture the response and send that as context to the next LLM. It would be very difficult unless and until I know that these are the only two things that I will do, no matter what the query is. Uh, the good thing about basically a loop is no matter which order you give it to, you could probably ask for weather only, and then in the next query you can ask it for time. It'll basically identify the relevant tool no matter what order you are asking the question in, and then hit the tool or call the tool and give you the response. So we know that we asked what is the current time in temperature in Bengaluru. So in the very first LLM call, it got the current time of Bengaluru, which is 9:17 a.m. on the 26th of July. So we know, and we'll see what it does next. So you can see if response dict and response of action is respond to user, we know that we have not sent that particular action. It will, what it does is it'll send that as context. Basically, the response user input is what is current time and temperature, and the response is the current time. So it's basically sending the query and the current time. That is a response that it got in the first LLM call as uh, the input, and wherein we just completed our first loop where we were able to get the current time, but we have not yet sent it to the LLM. So we need to send it to the LLM that we have received this response. Remember, it also has context of what the original question is. So here's what we are sending to the LLM right now. The LLM to the LLM we're sending the current time is this. That's the query. That became the prompt. Now the query is not what is the current time, but the query to the LLM right now is, or the prompt to the LLM is what is the current time. This is where the harness comes in. Uh, what we're doing right now is we are essentially appending the context that we had. So we know that we had the original query from the user, which is basically what is the current time and temperature. We are also appending what was the tool call that we made and what was the response we got from the tool. All of that is essentially added as context. And we'll still add the two tools that we have access to, and we'll compose a prompt with the full context now. So if I show you the final prompt now, and remember this is iteration 2. So our query is what is the current time and temperature? If we can, we're saying what is the current time and temperature. We're adding the context of the tool call that we made in the very first iteration and the response we got from the tool. And we're also adding the list of tools that we have access to, and our original system prompt continues to be the same. Uh, we're, we'll send that prompt to the LLM now, and we'll see what the response we get. So the response we got from the LLM is what is the current time and temperature in Bengaluru. The response we got the LLM is that actually the LLM now has identified, the model has identified that it has solved the first query of basically answering what is the time. Now it needs to solve for what is the weather like. So it has basically identified that, okay, it has access to a tool called a weather tool, and it needs to call that tool. So that's the decision that it has made. So the harness will take that, the loop will take that particular response, now and parse it and check whether if there is a tool called weather tool in the list of tools that it has access to. So we know that there is a tool called weather tool, and we'll invoke that tool now. So if I go back, so if you see as I'm following the debugger, we are in this, we have identified what the location is. The location is Bengaluru, and we'll send that particular location to the Open Weather API. We'll call that API, we get the response, and we will return this particular statement. The weather in basically in Bengaluru is, you'll see that response here. So the response is the current time is this. I'm sorry. The response is the weather in Bengaluru is currently overcast clouds with a temperature of 23.83 degrees centigrade. That's the response we got. So we know that that is still not the condition to basically return back, right? Because we just got a tool result. Now we need to give that tool result back to the LLM so that it makes the final response ready for us. So we are still in a loop. That's the beauty of a loop. We in each iteration we called. Let me take a step back. So here's what we've done so far, right? So we gave it a question: what is the current time and temperature in Bengaluru? The LLM decided to basically first get the answer for what is the current time. So it knew that there is a tool call that it can be made. It decided to essentially respond with what tool needs to be called. The harness took that particular response from the LLM and called the tool, right? And then the harness decided to again call the LLM with the response of the tool call as context and the original question of what is the current time and temperature. The LLM in the second iteration identified that there is the it has identified what it has access to the current time now. Now it needs to get the current weather, and it knows that it can call another tool. So it responded back with the tool name. The harness took the tool name, executed the tool, or basically called the tool, and it now has access to the current weather in Bengaluru, right? So but the job is not done. It still can't respond with this information. It needs to compose a final response now, right? So we are adding that particular information again, and we are basically adding that the tool response of weather, the weather tool call response as context. We build the context again. Basically, we compose a prompt with all the tool call responses. Everything, every iteration is part of the context now the tool has. And the tool, as you can see, it has decided that it will respond with the action called respond to user because now it has answer to the user's query. The query, the answer is the current time in Bengaluru is this, and the weather is overcast with the temperature of this. So it has composed the answer and has decided to respond with this particular action. I know that I don't have any tools called respond to user, so I'll exit the loop here, the for loop here, and we get the response from the LLM or basically from the harness. And we know that we have respond to user, as you can see, as the action, and we simply respond back. So if I show you the output here, we have the response from the agent. The current time in Bengaluru is 26/7/26, and the weather is overcast with a temperature of 23.83 centigrade. That's it. That's the beauty of how you can essentially make or work with an agent, or that's the beauty of using loops, so that you in iteration you can basically break down a large task into uh, subtasks and then execute each task one by one and then gather the final response and send it back to the user. A very simple concept. All right, we'll actually look at the anatomy of a loop. Basically, what does a loop essentially entail? Uh, what you're seeing is basically a very, very simple representation, a pseudo code here, and we've written a Python example of what this is. This is again coming from a lot of blog posts and research papers. uh, I want to compare the the loop that is basically standard across a lot of harnesses, famous harnesses like Claude Code and uh, Codex CLI and Pi and Hermes agent versus what we have written, and we'll see if that matches. So it says while true, basically while not done, call the LLM, and if the LLM responds with tool calls, you execute the tool, you add the tool to the messages, basically the context of the LLM, and then you call the LLM again. And if the LLM doesn't have a tool call and is returning a response, you return the response, right? Similarly, that's exactly what we have done here. If you ignore this part where we are basically doing some conditional checks, and this is something that you have to do as part of a good loop, and we'll talk more about it in a bit. We are basically calling the LLM. The process input essentially entails two things, right? We call the LLM and it also calls the tool. So if I show you this once again, the process input is essentially calling the LLM here, and it is also validating the response. Basically, if a tool call exists, it executes the tool. I have written it in a different format. Basically, I've written both the messages or both the methods. I'm calling both methods in a single method. Uh, but the idea is same here, right? So I'm checking if the input, I'm checking if the LLM is responding back either with a tool call response or the actual response. And I'm doing that validation here. That is basically, if it is a tool call response, I send it back as input again to the LLM, as you can see. And if I have a response to the user, basically an agent response, in this case, I'm sending it back to the user. That's it. I'm basically printing it here and I'm asking for the user's input again because I'm trying to run this as a chat, but you get the point. This is a common implementation across a lot of agentic systems. Now, if I can increase the size here, and that's what we'll be discussing now. We'll look at one particular iteration here and how this is essentially helping uh, a lot of these very popular harnesses in the market today. You have the uh, uh, Claude Code or Codex CLI. All of these are essentially using the same thing, and these are the steps. So essentially, if I can borrow this picture from the loop, I'll just reduce the size here. If you look at this is what is happening. You basically are capturing the context here in this bit. You're actually um calling the before you call the LLM, you're basically assembling the context, and this is basically your chat history and the context here. You are then passing that as input. This is something that's similar that we do. We were basically passing that as input or invoking the model by basically creating a prompt here and then calling the model here. You basically calling the model. And then the model responds with either a tool call. Basically, it says that, okay, you need to call a tool and gives us the tool object. That is the arguments of the tool. And if it basically comes with a tool response or basically a response and not a tool call, you take an appropriate action. And this is where the harness, basically the code that you've written in the loop comes into picture. You check if it is a tool call that you need to make. You make a tool call. That is, you have to write the code to do that. And if you're not making a tool call, uh, you're just simply returning a response. You basically send either of them to observe. So you validate what kind of output that is and you take an appropriate action. So if you find a stop condition, you exit this particular loop. And if you're not finding a stop condition and you have the tool call result, you simply call the LLM again. So this is a very simple call. And that's exactly what this pseudocode is telling us. In fact, all of these major harnesses, Claude codes, Codex CLI, the Hermes agent, Pi, and OpenClaw, all of them have a pattern or a variant of that particular implementation. It might not look exactly the same thing. They might probably adding a lot more, uh, custom methods or custom, you know, uh, ways of basically iterating and working and validating with the responses depending on the kind of problem they are trying to solve. But essentially, these are the uh, primary components of a loop. You have a symbol, you basically capture the context, the system prompt, the history, and this could entail agents.md, so many things, right? And then you basically, including the tools, and you send that to, you call the model, that is, you invoke the model. The model essentially could respond with either a tool call or an actual response. You basically act on that. Yeah, if it is a tool call, you essentially call the tool and you send that to observe. Observe essentially validates that particular response. If there is no stop condition in the response, it basically calls it to again, calls the adds to the context, and then the same thing, the same steps continues again. So this is common across all the harnesses, and in fact, I have the documentation of open of both Claude Code and Codex, and this is the diagram. So if you look, if I can increase this here, you see it is actually gathering the context here, which is basically a symbol. It is you don't see the invoke bit here, basically calling the LLM, but I think that's what you mean here. You basically invoke or call the LLM here. You take the action. That is, if there is a tool call that needs to be made, you take the action here and you validate the results. That is, you check for the stop reason. If the stop reason is there, you basically exit or basically say done. If there is no stop reason, you go back to adding the result back to the context here, and the steps repeat. Uh, there are also hooks where you can basically say interrupt steer or add context here, which you do in Cloud Code, and that is for some other day. Let's look at what Codex is doing. This is a very simple illustration, as not as detailed as uh, Cloud Code, but you get the point. They are doing pretty much the same thing. User keys in input, that goes input goes as an input along with some context. You don't see that here, but that's obviously happening to the model as prompt. The model essentially comes gives an output. The output is basically checked. That is, if there is a tool call, you basically call the tools and add that tool result back to the LLM, including the context, and call the LLM. If it's an agent response, you basically respond. The agent basically responds back the result to the user or anybody who's called it, essentially, right? So this is how the tool or the loop, I'm sorry, works in uh, in this is Codex CLI, right? Yeah, this is how it works in Codex CLI. Uh, we'll now talk about the stop reasons and when does actually a tool call, or sorry, when does the loop stop and what are the conditions, and actually what are the conditions that you need to apply if you're writing your own harness. What are the conditions that you need to apply for a robust, reliable loop, essentially. Okay, let's look at it. All right, this is probably the final section of the video, and this is probably the most important section of the loop as well. If you're trying to build the layer one of the harness, which is basically the loop and the loop in production, you need to have a solid defense mechanism. And we'll talk about all of those different techniques in detail in a bit. But it's important to understand what is the response that you're getting from the LLM provider that you're working with. Uh, let's quickly look at the two big ones, which is basically Claude and OpenAI. And I have essentially run a very simple prompt for these. I'm using the Anthropic SDK to basically work with Claude Sonnet 4.6. And the prompt is, what should I research for to find the latest developments in renewable energy? And the same prompt here, what should I research to find the latest developments in renewable energy for OpenAI? Look at the difference in the output structure. So uh, I have the output here. There is a content object. Basically, it's a array of objects. It returns an array, and there is citation, text, type. There is an output object which has a content field, and that is essentially an array of object. And there is type, text, log prop. So that is expected because obviously these are two different vendors. But the most important bit here is how does, if you're working in a loop and you're calling these LLMs and you're using their SDKs, how do you know when to stop? So this is the most important bit. In fact, these two, when it comes to Claude, and when it comes to OpenAI responses, this is the most important bit. In fact, I have a slide, and we can do a quick comparison of what that is. So the Claude stop reason and the OpenAI's equivalent is that if it is an end turn, basically Claude has given you the final answer. Then from a response point of view, right? Let's say it has given you the actual response. The status is completed here. If it is max tokens, basically you could essentially Claude may run out of tokens. The Claude model, that is Sonnet, may run out of tokens depending on the kind of context that it is working. Then it will basically, the stop reason could be max tokens. For you, which basically the status will be incomplete, and then you'll have to iterate over and find what the reason is, and the incomplete dot reason would be max output tokens. Same, there is something called as a stop sequence. And stop sequence is basically you give it a custom string. And if this custom string is available, then the iteration can stop, right? Here, it is completed, but there is actually no distinct essentially field that tells you what the stop sequence was. There is no concept of stop sequence. It is just the status will still be completed. Same with tool use. There is no explicit stop reason for tool use. Here, the status is still completed. However, you need to parse the function object, and I can show you that. You need to parse the function of output object. Yeah, here, this one, the tool usage output object, and parse the output. In fact, I have a small agent running in both, and we'll quickly see how this is working and what are the different states that we are hitting. So I will simply run this, and the agent looks very similar to what we have worked with previously, and we'll see what are the different stop reasons, and we'll see how the loop is working. So there is a while loop here, as you can see. We have taken in a task. The task is essentially user query. We are calling the Sonnet 4.6 or Sonnet 4.6 using the Anthropic SDK. And we are, once the response, basically once Claude gives a response, we are checking what the stop reason is. We're checking if response.stop reason is end turn, we simply return the block of text, right? If the response.stop reason is tool use, we basically then call the tool, just like we have written in our agent or in our loop. We basically check if the stop reason is tool use. That means we need to call the tool, right? And this is where the tool invocation happens. That means I'm iterating on what the tool response content is and what kind of tool it yielded, and we'll simply call the tool. You can see that there is a call tool method here. We call the tool and we simply append the result back to the back to the messages, and the messages is sent back to the client here like this. Again, as you can see, basically the loop kicks in again. If the stop reason is max tokens, then we basically raise an error saying that uh, the message got truncated after so many tokens per hit. Basically, it stops. If there is a stop sequence, basically if there is a custom string that the prompt or the user asked for in the system prompt, then if the LLM return with that response, we basically return the actual response back. So this is still a valid output. This is an error. This is the tool response, and this is a valid output. In this case, the uh, the it comes out of the loop. As you can imagine, the loop essentially stops. The loop terminates here. The loop doesn't terminate here because the tool call result of the tool call has to be appended back to the next LLM call. And if the next LLM call is basically an intern, then the output is given. Let's see what's happening here. So I'm going to run the OpenAI uh, agent as well. Okay, I didn't have to do this. I can probably run this one straight away. It's the exact same prompt that we are running, and we'll see how I'm printing the output. So, but we'll quickly see what the different states are. here, or at least different end stop reasons, uh, or the loop termination statuses are. So if you look at this, like we discussed, the if response dot status is failed, then we basically raise an error. If the response dot status is incomplete, we then check what kind of incomplete reason was that. So if the reason is max output tokens, then we say that okay, we're returning partial text because of so and so reason. Otherwise, we raise an agent error. If the status is incomplete, it could be for any reason like cancelled or in progress, or could be any reason. We basically raise error here. Uh, I'm sorry. If the response has an output text, we simply return the response. And there is, as you can see, there is a function called the output. If the output has uh, a function call appended to it, then we simply call the function. So we are checking if the output has the function call object returned. And if the function call object exists, that is it. We have tool calls. We simply iterate over the tools and we simply call them. We append them back to the messages output uh, and basically the input items here, which is basically messages from Claude that we saw. And that is added back as input to the LLM. The LLM then calls, and if it is returning a final response, the response is given or yielded back to the caller or the user, right? So very different implementations of how or when the loop gets terminated, but you get the point. Now this is important to understand because in your harness, and if you're working with different terminals, or sorry, different models, you need to essentially write or manage or handle these conditions and explicitly and work with them. Now let's look at the let's look at the stop conditions and the multiple items that we need to essentially keep in mind to build a robust production loop, right? So max iterations. A max iteration is basically a hard cap, right? So you can imagine that if you don't give this as part of your config, if you're working with LangGraph or if you're working this, you can basically add, then you can keep a counter in your while loop, and then if it exceeds a specific number, you need to basically add that as a condition. If it is equal to or is greater than a specific number, then you need to basically exit that loop with whatever response that you have captured. So it's a hard cap. It's basically in production system is basically between 20 and 25. So as you can see, this alone is basically arguably the single most important safety control in your whole loop, because without it, a model that keeps deciding to call has zero structural reason, and it is probably going to give you a lot of pain in terms of the token bill. Your API bill is going to be very high, and obviously you'll be wasting a lot of time. If it just keeps iterating, and there are a lot of reasons why a model will simply keep it, iterating. Obviously, a wall call timeout, independent of step count. This is basically you don't want a handful of slow tool calls to basically burn uh, a lot of tokens for you, and then you're getting unacceptable latencies. You don't want that, right? You want to essentially step that. For each iteration, if there is a timeout, you want to essentially exit the timeout or exit the loop. There is a goal completion check. You want to have an explicit check of what is basically finished for you, what actually is basically the output for you. And if you don't want more tool calls, if you don't want more iteration, if a specific context-based condition is matched, you need to basically exit out of the loop. Similarly, if there are repeated tool calls, if the model is calling the same tool with the same arguments over and over again, that's a strong signal that it is stuck and it is not making progress. You need to essentially watch out for this and write a condition for this. You can say that if you're capturing the same uh, if the same tool is being called with the same arguments, that means nothing has worked out and you need to essentially exit it. It could be an error. There is a possibility that there are recoverable errors. Some errors basically, for example, if a tool essentially is calling an API and that API has very high latency, or if that API returned a 404 or for there could be anything, right? There could be a network failure. you should simply terminate. And you need to basically watch it for that. You're in your context, in the harness that you're working in, the kind of problem that you're solving, this could be very different. But you need to have essentially a termination logic for an unrecoverable error. Uh, I think one pattern also worth stealing is when you hit the max iteration cap, don't just cut off the user. Basically, don't immediately return uh, the final message. You would want to, before you hit, let's say that you have given the max iteration as 25 steps. If you are at the 24th step, you might want to essentially you know add an extra context or extra message in the prompt or instruction in the prompt that you have hit the step limit, give your best answer now, and make one last call. Basically make the most of your 25th call, and try and convert this basically into a degraded but a useful answer. uh, that should also be fine in certain cases, but again, you would want to maybe set up that in a config file, that if the user wants a degraded answer, that is also fine. Some people might want it, depending on the kind of problems that we are working with. Um, so 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 the loop has stopped now. What does it actually leave behind when it does? Let's actually look at that. This is the final section, and we have to understand this one, right? Because if you look back, let me go back to the first slide. Uh, if you get the terminal, basically the terminal state right, and your layer 4 basically durable execution, the durability of your agent will be so much more better. What I mean by that is uh, you need to essentially ensure that the bookkeeping of your agent, that is the state that the agent or the loop leaves the agent in, is that much more important for the durability, so that you can build checkpointers and then resume from where you have left off. Some, I think, states that you want to keep in mind is that a normal completion is when every tool is matched with its tool result. Uh, the maxed and exceeded is basically the model didn't finish within budget, but the history has stays well informed or well formed. Sorry, aborted midstream. Basically, there is a hook that you've given, and then you've stopped uh, the loops or the iterations. uh, history remains still History is still well formed, right? So that you can still use the checkpointer and go back to where you want to continue. You've captured the history well. Aborted after dispatch, but before next call. So these are multiple different states which you will probably use in layer 4 uh, for all the terminations, and your agent could terminate, or the loop could terminate for any of these reasons. So ensure that you when you do a good job here, for you to basically use a checkpointer and go back to the state that you were in and resume from there is going to be that much more easier. All right, folks, that's it from this particular video. In the next section, we'll talk about layer 2, which is basically tools and permissions, basically tools and guardrails essentially, and we'll dive deeper into it. Thank you so much for watching. If you haven't subscribed, please do subscribe, and watch out for the next one. Thank you.